There are a number of challenges for a stand that is moving towards regeneration, including overstory density, interfering plants, retaining diversity in the seed source, and deer. Overstory density refers to the relative amount of shade the canopy casts on the forest floor. Light is an important consideration when seeking natural regeneration. Competition for light affects seed germination as well as seedling growth and development. Most tree seedlings benefit from at least 50% blue sky. Thus, management decisions must consider the competition for light resources. In a closed canopy forest, light reaching the forest floor is normally of two types. In partial shade, the light is diffuse or scattered, and there may not be enough light for seedlings to carry on photosynthesis effectively. Sunflecks are the other type of light that reaches some seedlings. These are small patches of bright light that reach the ground through small canopy holes. Sunflecks move quite rapidly across the forest floor throughout the day, and seedlings only have small spurts of sunlight to use in photosynthesis. In each case, diffuse light or sunflecks, the lives of these seedlings are precarious due to this overstory density. Therefore, reduce shade from a dense canopy so seedlings can receive an adequate amount of light. This is an important part of the regeneration process. In addition to overstory density, competition from interfering plants, and retaining adequate diversity in the seed source are significant challenges for regeneration. These shade-tolerant ferns are one common example of an interfering plant. When there is low shade on the forest floor, from ground level to 20 feet, tree regeneration is problematic. To lessen the seedling's competition for sunlight, one regeneration prescription might demand an herbicide application to the ferns. Retaining adequate diversity in the seed source is also important for regeneration. Failing to consider species mix can lead to less diverse forest conditions, as the easily regenerated species tend to become more common. Poorly planned cutting practices can easily reduce species diversity, which then affects the diversity of seed sources. Species diversity helps achieve resilience, the ability of a forest to withstand disturbance. For example, if an insect or disease damages a particular species, and that is all there is in the stand, you can foresee the consequences. With the loss of that species, no viable seed sources remain, and the site is at risk to dominance by competitive plants. You may have seen this in Pennsylvania with the hemlock and ash trees. The image on the left shows a dead hemlock tree, the result of hemlock woolly adelgid, and the image on the right shows dead ash trees, the result of emerald ash borer. We are left asking, what will replace them over time? Considering how to retain diversity in the seed source will help ensure species mixes in the future forest. This is an example of diversity in a seed source. There is a species mix of advanced regeneration including red oak, maple, cherry, and ash. There is some grass or sedge competition, but not enough at this time to cause concern. The seedlings are large in size and ready to grow. In addition to overstory density, interfering plants, and diversity in seed retention, deer pose a great challenge for regeneration. Deer are common in many forests, and it is easy to overlook their impact on forest regeneration. Nonetheless, research repeatedly shows that they can and do change forest functions, and are therefore a critical consideration when seeking to regenerate a forest. Since the early 1930s, there have been too many deer across Pennsylvania. Their overpopulation has caused understory conditions to change, mainly by their browsing on plants they find palatable. In the process of reducing numbers of some species, deer inadvertently allow less tasty plants to increase in numbers. Some of these plants are native, and in others are non-native. In either case, they are often competitive with tree regeneration. Examples of native plants deer do not favor include mountain laurel, hay-scented fern, New York fern, bracken fern, striped maple, as well as other species. Deer eat browse, the twigs and leaves of desirable species. Normally, browse does not exceed the diameter of a common pencil. This is an image of deer browse on striped maple. To better understand the profound impact deer can have on a forest system, let's do some math. An adult deer requires about 4 pounds of browse each day to survive. Approximately 400 twigs make up 1 pound of browse. How many twigs does a deer eat in one day? 4 pounds per day times 400 twigs equals 1,600. One deer eats about 1,600 twigs each day. In 1 year, how many pounds does one deer eat? Multiply 4 pounds per day times 365 days per year, and you get about 1,460 pounds of browse each year. That's 3/4 of a ton. If one deer eats about 1,460 pounds of browse per year, and a forest has 20 deer per square mile, how much browse would be eaten in 1 square mile of forest in 1 year? The answer is almost 30,000 pounds per square mile, or 15 tons. Now, how many twigs would that be? In 1 year, one deer would eat about 12 million twigs. With a home range of a square mile, that would be about 18,750 twigs per acre. Further, if a doe is pregnant or lactating, she may increase her food intake to 10 pounds per day, and a buck growing antlers also needs 10 pounds per day. However, in some areas of Pennsylvania, deer numbers are now more closely balanced with habitat resources. Understory conditions are slowly recovering to a better balance of preferred and non-preferred understory species. Yet, when there is little for deer to eat, the browsing of only a few deer can cause tree seedling and sapling numbers to dwindle. Foresters have several quantitative tools for assessing advanced regeneration conditions. Silva, oak silva, and ORSPA are 3 research-based tools foresters can use to help assess advanced regeneration by calculating sprouting potential from stumps and factoring in competitive plant conditions. It is important that landowners seek this advice before harvesting. Attaining successful regeneration is a process that may take years to decades to accomplish. It is not an event. That is, we cannot simply harvest a forest and assume that regeneration will be adequate and of the right species for the site will be present. By considering the challenges of overstory density, interfering plants, retaining diversity in seed source, and deer browsing, landowners can better plan for successful forest regeneration.